Hello everyone. This video we will be going to discuss about consistency. This is the criteria. This is the another criteria for good estimators. Last video we had discussed various criteria for estimators. That is unbiasedness we had discussed. Now we will be going to discuss another criteria for estimator, that is consistency. First we will see the definition of consistency. An unbiased estimator is said to be consistent if the difference between the estimator and the target population, the true population parameter theta, that means it should be become smaller when we increase our sample size. Formally, an unbiased estimator mu cap for estimator mu is said to be consistent if variance of mu cap becomes zero or approaches to zero. When our sample size we have to increase near to infinity. Next, we will see another definition. An estimator Tn equal to T of x1, x2, etc. xen. Here we have more and more estimator. This estimator Tn should be unbiased. Okay. This estimator based on a random sample of size n. Random sample of size n. Now, this estimator Tn is said to be consistent estimator of gamma of theta. This true population parameter theta belongs to the parameter space. If the Tn, the estimator Tn converges to the consistent estimator gamma of theta in probability. That means we have to increase our sample size. We have to increase our sample size. That means the Tn is a consistent estimator of this gamma of theta when the sample size should be large or the sample size we have to increase or tends to infinity. Next, we will see some remarks about consistent estimator. If x1, x2, etc., xn is a random sample from population with the finite mean, expectation of xi equal to mu. This population mu is less than infinity. Then by Stinch's weak law of large numbers, we have xn bar equal to 1 divided by n summation xi. This is the our sample mean follows. Sample means we converges into expectation of xi equal to mu. Expectation of xi equal to mu when our sample size should be large or the sample size tends to infinity. Okay. This now next we'll be going to the conclusions. Hence, the sample mean xn bar is always a consistent estimator of the population mean mu. This is the some remarks about consistent estimator. We'll see one example. The variance of the sample mean x bar is sigma squared divided by n. Okay, this is the sampling distribution of the sample mean x bar. Its variance is sigma squared divided by n, which decreases to 0 as we increase the sample size n. When we get the sampling distribution of sample mean, variance should be 0. Means we have to increase our sample size. We have to increase our sample size small n. Hence, the sample mean is a consistent estimator of mu. This is the some example for consistent estimator. Thank you.